Okay, so guys, in this video, let's solve some question which came in 2023 paper 2 GCE. Let's get into it. Question 8a. The diagram shows the frustum of a cone. Perpendicular height is 40 centimeter. The top and bottom radii are 10 centimeter and 30 centimeters respectively. Take pi as 3.142. Calculate the volume of the frustum. So finding a volume of a frustum. So a frustum, it has no formula. So therefore, what we're going to do is we extend this frustum, making a cone. So extending a frustum so that we form a cone, extend it like that. So that means that we now have two frustum. I have this small, I have this small cone, and also a whole big cone. So I have two, a small and a big. So we need to know this height for a small cone, which we don't know. So we need to know that height. So how are we going to solve a height for a small cone? So solving a height for a small cone, you're going to use a small over big. So small height, which is our x, that x there. So I will say x over, so for big it is this height for the whole thing, starting from there up to down here. So there I have a x, and here I've been given a 40. So for a big, I will say 40 plus x is equal to, and then I get these sides. Here I have a 10 for a small, and big I have a 30. So it will be 10 over 30, like that. So I can cross multiply. So cross multiplying, it will be 10 times, x times 30. I'm getting a 30x is equal to 10 times 40 plus a x. So it will be 30x is equal to 10 times 40. I'm getting a 400 plus 10 times x, it is a 10x. So now I can correct the like terms. Correcting the like terms, it will be 30x. So a 10x will come beside and becomes a negative 10x is equal to a 400. When you subtract 30x minus 10x, we are getting a 20x is equal to 400. Solving for x, I divide both sides by a 20, this side by a 20. So a 20 and a 20 will cancel. What remains is a x is equal to, so 400 divided by 20. What I'm getting is a 20. So here I'm getting a 20. So what does that mean? So that means that my Kx, that Kx, which is representing a small height, so my small height is equal to 20 centimeter, where my big height, which I'm solving as 40 plus ax, so it will be 40 plus x, it is a 20, and I'm getting a 60 centimeter. So 60 centimeter is my big height. So my big height is equal to 60 centimeters. So now I can go on and find the volume of a frustum. So finding a volume of a frustum, use this formula. We say volume is equal to 1 over 3. It is base area times height. But for a base area, you know that this area down here of a base, we know it is a circle. So for a circle, we use pi r squared. So I'm using pi r squared and ah. So this one is for a big cone. Again, minus 1 over 3 pi r squared h. That one is for a small cone. So I can say v is equal to, I can factorize what is common. It is 1 over 3 and a pi, open bracket here, I mean if a r squared h minus r squared h. But if you want, you can use VC, same one, you get the same answer. So we say v is equal to 1 over 3 pi, open bracket, r, which is my big radius, I have a 30. So it will be 30 squared times height, which is a big height, I have a 60. So here I say times 60 minus small r, I have a 10 there. So it will be 10 squared times h, which is a small height, I have a 20. So yes, I multiply by a 20. So it will be v is equal to 1 over 3 pi, open bracket, 30 squared, I'm getting a 900. So it is 900 times 60 minus 10 squared, it is 100 times 20. So my v is, my volume is equal to 1 over 3 pi, open bracket, 900 times 60, it is a 54,000. So I have a 54,000 here, minus 100 times 20, it is a 2,000. So my v is equal to 1 over 3 pi, open bracket, 54,000 minus a 2,000, I'm getting a 52,000. So I have a 52,000 here. So my volume now, I can say volume is equal to 1 over 3 times pi, it is 3.142. We are multiplying with a 52,000 to 3. So when multiply, let me just write on top, I create some space on top here. So multiplying, getting a volume is equal to, getting a volume to be is equal to 54461.333. So the 3 will just keep on going. So finally, our volume is equal to 54461.33, which is in centimeter cubic. So that's our volume. So for part 8a, we are done. Let's now do our part 8b. So part 8b, it came under F geometry. So for F geometry, so F geometry, it is 8b. So for 8b, 4 towns, A 70 degrees north and 65 degrees west, B 7 degrees north, 65 degrees east, C 7 degrees south, 65 degrees east, and D 7 degrees south and 65 degrees west on the surface of the Earth. Take pi as 3.142 and the radius 3437 in nautical miles. Sketch the surface of the Earth showing all the 4 towns A, B, and D. So when it's sketching, let's sketch our surface of the Earth. I'll sketch it this side. So that will be my surface of the Earth. So I have how many latitudes? Latitudes they run parallel to the equator. So those are my latitudes. So latitudes I have two because 70 north and 70 north they are the same. So I will draw one latitude here which is to the north because this side is the north, this side is the south. So I have this latitude which I'm calling a 70 degrees north. I also have other latitude which is 70, my 70 degrees south. Those are the two latitudes which I have. So what about the longitudes? So longitudes I have 65 west. I also have 65 east. The rest there east and the west. So I also have two 65 west. So this side it is to the west. That side it is to the east. So for west, I'm drawing the longitude here. Let me just draw it well. I'm drawing a longitude and the other one since I have two of them. So those are the two longitudes. So this one will be this one is my 65 degrees west. So 65 degrees west, and this one will be my 65 degrees east, like that. So for sketching, that's it. So we can locate the points. We put the points A, it is 70, 65. So 70 north and 65 west. So my value of A, it is there. And then B, it is 70 north and 65 east. So my B is here. That's where my B is. And then for C, 70 degrees south, 65 east. So here, that's where I'll have my C. And then my D, 70 degrees south and 65 degrees west. So I have here my D. So that's for sketching. So let's go to B, B2. So on B2, we said calculate in unit miles the distance AB. So find a distance AB. So that distance AB, it is this distance here from A going to B. So as you can see, distance AB, it is in the same latitude, in this latitude which is 70 degrees north. So finding a distance for points in the same latitude, we use theta over 360 times 2 pi r cos x. That's the formula we use when finding the distance of points which are in the same latitude. So where theta is standing for the difference in longitude, x standing for the latitude where they are lying. So we can find our theta. So theta, which is the difference in longitude, because A and B they are in the same latitude. So find the difference in the longitude. B is in longitude 65 and C is in longitude 65. Since they are on different hemispheres, that one is on the east and west. So I'm going to add those two longitudes. If they are on different, you add. So it will be 65 plus 65. So I getting our theta to be 65 plus 65. I getting a 130 degrees. So where is theta? We are putting a 130 degrees. And then cos x. So our x, this AB. So A and B. So this A and B, they are in this latitude. So we are falling on this 7 degrees north. So 70 will be our x. So we can simply substitute. So we say AB is equal to theta. I have 130 over 360 times 2 times pi. It is a 3.142 times radius. It is a 34. Radius are getting a 34, 37, 34, 37, and then cos x, it is a 70. So we can say AB is equal to, so here we can multiply. You multiply, and let's multiply 2 times 3.142 times 34, 37 times cos 70. I'm getting a 130 over 360 times 7386, 7386.987994. So again, when I multiply a 130 times 7386.987994, I'm getting, so AB will be is equal to, I'm getting a 963 308.4392 over 360. So when I divide that by a 360, I'm getting my AB to be is equal to 2667.5234442. So now I can round off that answer to two decimal places. So rounding it off to two decimal places, I'm getting my AB is equal to 2667.5.52. So 667.52, which is in nautical miles. So units, it is nautical miles. So that's our distance AB. So for part A, we are done. This one was our part A. So now let's solve our part B. So finding our part B, we want us to find BC, the distance BC along the longitude 65 degrees east. So let's say so this is our B. Want us to find a BC. So BC, we have a B going at that C. So that one is in a same longitude. So for distance of points in a same longitude, we use theta over 360 times 2 pi r. So for this one, it's just 2 pi r. It doesn't have a cos x. Then now to differentiate. So we say BC. So where theta, first we need to have a theta. So theta in our case, it is the difference of the difference of latitudes. So we are in the same longitude. So get a difference of these latitudes where they are falling. So the key point here is if they are in the same longitude, you get a difference in latitude. It is the opposite. So I get in, since they are on different hemisphere, we have 70 north and 70 south. For different hemisphere, finding a difference in the longitude, you add. So we are adding a 70 plus 70. So 70 plus 70, are getting a theta to be 1 will be 140. So theta is equal to 140. So that's our theta. So we can go ahead and find BC. So BC is equal to theta 140 over 360 times 2 times pi 3.142 times r 34.37. So BC is equal to, so when you multiply 140 times 2 times 3.142 times 34.37, we are getting a 32,375.12 over 360. So BC is equal to, when we divide that one, we are getting 8399.264222. So we can now round off to two decimal places. So finally our BC is equal to 8399.26, which is in nautical miles. So that's our answer for this video.